Today we are going to start our object-oriented programming in Python full tutorial, and I'm going to cover everything you need to know about object-oriented programming. The beautiful thing about object-oriented programming is that if you understand the concept, then you can use it in any language. So that is one thing you need to bear in mind. If you understand the concept, let's say you are able to use it in Python, then you can use it in C++ or Java or any other language. So right now we are doing review of OOP terms, and that is really very important because if you don't understand the concept and the terms, then you are not able to apply correctly. So let's review a few terms. Now these terms we are going to review, they are available here in my website, kindthegenius.com/Python. You can see this tutorial and you can easily get this list. So a class variable, data member, function overloading, instance variable, instance, inheritance, instantiation, and operator overloading. There are a whole lot of other terms that you would like to learn. I'm going to provide later, but for now, these are the basic ones you need to know to understand object-oriented programming and be able to use it. So let's take, for instance, we have a class, because if I'm defining, then I'll also be giving some example. I'd like to remind you to subscribe by clicking the subscribe button below so that you get notified when I make new lessons. Alright, so a class is a blueprint for a new object. A class defines the attributes and behavior of an object. The attributes are data members, instance and class variables, and the behavior is represented by methods or member functions. So what are we saying? If we have something like in Python, you can say something like name is equal to kindson. So in this case, we have, let's say this is an object, and it has the variable name contains this object. So it's a string of items. Let's say it's a string of items. So it can be stored in memory and defined using a variable name, as you can see. But now, what if we want to define a variable like a computer or something like a pen? So in that way, we need to create a blueprint to be able to define this object. So that is what class is all about. You need to create a class. A class is like a blueprint. For instance, you have something like a template you use to produce different things. So let's create a new class. Let's say we have a class that represents a computer, for example. So it means the first thing you want to ask yourself is, what are the attributes of a computer? A computer has a keyboard, it has a mouse, and it has a monitor. So if you are creating this blueprint, you need to specify all these items. All right. So let's look at the definitions first before we go to start implementing them. What is a class variable? Is a variable that is shared by all objects of the class. So when you define a class variable, it is defined inside the class and outside the methods. So what are we saying? A class variable is a variable that you don't need to create an instance of this class before you can use it. So a class variable is equivalent to static variables in something like Java. So in this case, you can use this variable just with the class name. You don't need to say new object before you can use it. What are data members? Data members are variables defined in the class. They are used to hold data associated with the specific class. So we are going to look at that as well. So as we are going to implement our classes right now, we are going to see how all this applies. Function overloading, you use function overloading to create two functions with the same name. So you can actually have two functions exactly the same name, but they perform different operations based on the arguments. What of instance variable? These are variables that is defined in a class but belongs only to the particular instance of the class. So now this instance variable is completely opposite of class variable. So an instance variable belongs to objects created from the class, while a class variable belongs to the class. So for you to use an instance variable, you must create an object of this class before you can use an instance variable. So we have instance means an object created from a class. So, and if you are creating an object from a class, then it's called instantiation. Instantiation, yeah, that's the name. So when you create a new object, after creating a class, you can now use this class to be creating new objects. As many objects as possible as you want, you can be creating it, provided you have actually created or defined a class. What is inheritance? Inheritance is a feature that allows a class to inherit properties from another class. So think of it this way. You have something like some recipe to prepare some kind of meal. Okay, so if you want to prepare a different meal that is a bit different from this one, you can actually copy values from this existing recipe and then use it to make up a new one. So in this way, you inherit from something that is already existing. So instantiation, we've already defined it, and it's creating new objects from a class. Operator overloading is similar to function overloading, but in this case, you have an operator to perform more than one type of operation. So for instance, we have plus. The plus operator is defined to perform addition of two integer or two float numbers. Or in fact, it adds two numeric data. So plus is not defined for maybe a string or something like a vector. So if you can make a plus sign work for a vector or any other data type, then it means you have overloaded it. So while it can perform integer addition, it can also perform list addition or string addition and so on and so forth. So we've covered review of OOP terms, so I would like to recommend you take some time, try to read up this and understand, be able to define it in your own words, just in case you may need it in some ways. So we now move to the next part. Alright, so this will be the second tutorial in our object-oriented programming in Python full tutorial. So today we are going to be talking about creating a new class. As I've mentioned before, in my website I provided the code snippet you need for this tutorial. So easily just go to the website. I provide a link in the description box, and also you can just get there by typing kindtonthegenesis.com/python, and then you can find this tutorial. So what I'm going to do, I'm going to actually copy this code snippet and paste it, then we can go through it line by line to understand what is happening. So we are creating a class that represents a student. So let me take out this comment so that it becomes a little clearer. So, okay, so we are creating a class that represents a student. So now we have class student. So the syntax says you need to use class student first. I don't know why we have this error here. Expected 2 blank lines found wrong. So just enter here. Good. Okay, here if the indentation is not a multiple of 4. So it means we need to use four spaces. So like this, one more. So it goes. Alright, so I can just shift this, I can shift this, I can shift this as well. Again, I can shift this, shift everything. So in that way we have all these warnings, so it just go. So just, okay, so I think everything is fine. So we have class student. So what we are saying here is that we are creating a class called student. So let me just comment it. Create a class called student. Okay, so we have an error here. Unexpected indent means what? Okay, so let me just ignore it for now. Okay, so okay, fine. So we have a class called students. and now we have number of students is equal to 0. Remember, we say that there are some variables that belong to the class. So number of students is holding the number of students that has been created so far. So it means that this is a class. This is a class variable. This number of students is actually a class variable. So this is really good. So let's use this. This is comments. All right. So number of students is a class variable. Now let's look at the next line. def init. So this is a function or a special kind of function. This init. So this is called a constructor. So this is called a constructor. Constructor is used for creating new objects. So in all the classes you create in Python, you always will have a constructor. So now after writing the constructor, you have in brackets, you should have the attributes of this class. So inside these braces, you have self. So this will always be there as is part of the syntax. Then following that, you need attributes of a student. For instance, the reg no or the registration number, the first name, the last name, the email address, the phone, and everything comes here. And then the next thing you want to do is self.regno is equal to regno. So what it means is that when you are creating a new object, you expect that the user calls this function and then provides reg number, first name and last name, and it creates a new object. Alright, so now when this function runs, this function init, a new object is created, or we can say a student is instantiated. So if a new object is created, then it simply makes sense for us to increase the number of students. And now remember, we say that number of students or no of students is a class variable that you have to use it with the class name. So you have student.no of students is equal to 1. Alright. The next one is display count. So this is a function or a member function that you use to print the total number of students. So total number of students is %d. So this is a format specifier. And then you provide the value you want to replace it with. So we also have print students, right? So this is display count and this is print student. When you call print student, it displays the reg number and it displays the name. Alright, I'm going to go ahead to right click and run this. So if I run it, you can see that nothing happens. The reason nothing happens is when you create a class, nothing really happens until you use this class. Again, this is the definition or explanation of what I've been saying in this particular lesson. So you can read it up, or you can pause this video and rewind to listen more or to understand a little more. So now we are going to use this class. Now, assuming that this class is complicated, let's create a simple class, just a class that just have a student and his name. So and say, or let's call this class pupil, class pupil. So now you can say def init def space init, and now we have self and now we have name. Okay, so you can just say self dot name is equal to name. Okay, so as it is, this is also a complete class. So creating a class, this class have just one instance variable, and that is thing. So this is basically how to create a class, and I'm going to stop here the next tutorial we are now going to discuss how to use a class or how to instantiate a class. I'd like to thank you for viewing. We continue with tutorial 3, and today we are going to be looking at creating objects from classes, and the process to create an object from a class is called instantiation. For you to create an object, you need to use the name of the class and also the parameters to the init function. So when we created this class, we have this init function and we have 1, 2, 3, 4 parameters. The first parameter is not to be used. So let's take, for instance, we want to create, so let me take out this one. We want to create a new student, and now I created 2 students, and I'm going to copy them and paste them in my code here. So Control V. So I've actually created 2 students. Take out one space so that it doesn't give me this error. So student 1 is equal to student. So this is the name of the class, and you specify these parameters 1, 2, 3, the reg number, the first name, and the last name. So when this line executes, let's say this student 1 is equal to student 001. So let's look at here. When this line executes, or when this line is encountered, what happens is that the program goes to run this function. So it runs this function, creates this student, and then also runs this number of students is equal to number of students plus 1. It increments the number of students by 1. So at the end of this line, the second student is created, and then the number of students is also executed, and at this time the number of students is 2. If I run this code, nothing happens also because we are not printing out anything. So we've created 2 students. These two students are simply created in memory. So let's now call the method print student and see. So the method print student is actually this method, right? So this print student, if is encountered, this code or this function print student is run. So let me paste it. Oh, sorry, no, yeah, student1.print student, student2.print student. So if I execute this, you can see that it runs and displays reg number 001 name. So let's OK, and then reg number 002 name treasure money. So you can see that print student executes this line. So I have reg number self.regNum is the name of the reg number for the particular object. So when we say here student.self.reg number, it refers to the reg number of the particular object. Let's now use number of students as well. So this way I'm going to print out number of students. So you can see number of students is 2. So what it means is that each time a student is created, number of students is incremented by 1. So I'd like to recommend you take some time to go through how to create objects. So this is basically how it works. Know about the init function, and also know about these are instance variables and this is class variables. So let me just write this so that it's something you need to know, the difference between instance variable and class variable. All right. So let me just illustrate the difference once more. So if, for instance, I come to say here student1 dot number of students, this actually is going to give an error. So if I run it, okay, so I have student1 dot number of students. So basically, so let's say student1 dot number of students. So just a second. All right, so this is what I'm trying to do. Okay, so it also works student1 dot number of students. So this is what it means now is that class variables can also be used with the instance. So, but what it means is that you don't need to create an instance to use a class variable, but you can also use a class variable with an instance. Alright? So I'm going to take out these. I'm going to stop here, and now the next tutorial will continue with assessing attributes. We are going to be talking about assessing attributes. So what are attributes? Already you know that attributes are members or attributes of a class. For instance, we have the class student. The attributes are 3 attributes: right now, first name, and last name. So these are attributes of the student class. And now we want to see how we can assess these attributes using the inbuilt functions that are given by Python. So this function, we are going to test them. The get attribute is used to assess the attribute of the object. The has attribute is used to check if an object has an attribute. The set attribute is used to assign an attribute, and if it doesn't exist, it is created, and the del attribute deletes an attribute. So let's go to see how it works. Remember to subscribe if you've not subscribed. And now let's see. So let's print if, okay, let's start with get attribute, and this first we need to create a new object first. So let's just take these two, because you use these attributes for objects. All right. So let's say we now say print get attribute of student1. And what attribute do we want to get? We want to get the attributes, the attribute of first name. Good. Now, if I execute this, it's going to give us the attribute first name of the student1, right? So you say get attribute, and then you use the name of the object and the attribute you want to get. Note that this can also be printed or handled in this way: print student1 dot get attribute dot first name. So it's also about the same thing, but this is an inbuilt function in Python that helps you get this attribute. Further in this tutorial, you'll see why this is necessary for you to know how it works. Now let's try to use the has attribute. Okay, let's call the full name. So let's use has attribute. So in this case, if I run it, it's going to say true, because student1 has the attribute first name. Let's say grade. So is there grade? The answer is false, as you can see. Let's now use set attributes. So in this case, we want to set attribute of student1. And we want to set the attribute. Now we have the object, we have the name of the attribute, and we have the value. Alright? So let's say we want to change the first name of student1. Student1 has a first name of Solis, and we want to change it to first name. We want to change it to what? Let's change it to trust. Alright, so if I come down here and then say student, if I print out the value of student1, dot first name, is going to give us the new attributes assigned. So you can see trust, right? So set attributes student1 first name, but I don't need to use a print statement in this case. So it simply assigns it trust, right? So that is how the set attribute works. What of delete attribute? So if I delete, let's say Let's delete. So in this case, let's delete the student1 first name attribute. Let's delete the first name attribute. And at this point, I've deleted the first name attribute. And if I go ahead to print it, it now says student1 object has no attribute first name, right? So because we run the delete attribute here and it deletes the attribute. So you need to keep this in mind. So these four, try to take some time to practice them. You can copy and paste my code and run it to see how it works. Today we are going to be looking at built-in class attributes. So Python provides some built-in attributes that you can use for certain operations. And just like normal attributes, these built-in attributes can be accessed the same way. So the first thing you want to understand is that we have built-in class attributes. So these are class attributes, meaning that you need to use them you can use them with the name of the class. So meaning that if you have this class, you can access the date, the doc, the name, the module, and the basis. All right, good. So the date is a dictionary that contains a class namespace. So we are going to use them one by one and actually see how it works. So assuming we have this our class, and let's start by using the doc. So I want to print student.doc. So let's copy and paste, and then this time we have student.doc and we have student.doc. So it says student.doc is noun. So what is doc? Doc is a class documentation for this class. So for now, we don't have any documentation for this class. The next one we are going to try is date. So let's use date. So I'm going to run it and it says none. So date is dictionary that contains the class's namespace. So in this case, there is, yes, actually, date, good. So it should have something. So we have a dictionary of namespace. We have module, we have main, we have module is main, they have no of students 0, and we have init function. So let's shift right. Okay, so remember this is a tuple, so we have comma separates the different items. So init is a function student init at this memory location, and we have display count. This is the class variable for the student. So you have function student the display count, and we have print student. This is not a class variable but a method defined in this student class, and so on. So take some time to go through these bits. So it's a tuple that contains the class namespace and all the items in it. So let's look at the next one. The next one is name. So name is simply the name of the class. So if you run it, it's going to just tell you the name of the class. So the name of the class is student. That is very easy. Then we have module. Module is the name of the module where the class is defined. This attribute is main in interactive mode. So let's see. So we want to see the module where this class is defined. So I'm going to run it and it says the module where this class is defined is main. Alright. Now I have bases. It's a tuple that contains the base classes. So are there some base classes? For now we don't have. And it says it's listed in order of the occurrence in the base class list. So let's see. And this is basis. So when we are going to talk about inheritance shortly, then you are going to understand what base classes mean. So if I run it, it says it's a basis class object. So basically there is no base class we have defined for this class. So these are built-in class attributes you need to know. Again, you need to understand that this is something you need to know if you need to be a good Python developer, even though you are not going to use it much. But know that these class attributes, they are provided by, they are inbuilt by the class. You don't need to define them. You can just use them. So have dict, doc name, module, and basis. So in our next tutorial, we are going to now look at garbage collection in Python. We are going to now examine garbage collection in Python. So in this case, we are not really going to be doing so much writing a program, but we need to explain the concepts of garbage collection. So what is garbage collection? Garbage collection has to do with to remove objects that have gone out of scope or that doesn't have any more references. So basically, there are objects that has been created, but they are no longer to be used. They are removed from memory to free up memory space. Python uses automatic garbage collection. So because you might meet this question in a quiz, Python implements automatic garbage collection, meaning that you don't have to worry as a programmer about deleting unnecessary objects. That having been said, you also need to know that Python actually runs garbage collection when the program execution starts, but this garbage collection is triggered when no more references exist to this object. So we can say that the object reference count is 0. So this is one thing you want to know. Anytime an object reference count is 0, automatic garbage collection is triggered to take this object out of memory. An object reference count is increased when it is placed in a collection or assigned a new name. And similarly, the object reference count decreases when it is deleted with the del command, or its reference is reassigned or it goes out of scope. So let's illustrate this a bit. So let's take three variables x, y, and z. At the start of our program, when this variable has not been used, so at this point, let me just use some comment to clarify. Objects reference counts for x, y, z is 0. Now, if I execute this code, x is equal to 20. Here at this point now, what do you think have happened? Object reference count of x have increased to 1. Expected 2 blank ones. Okay, no problem. So in this case, object reference count for x, let's just call it objects ref count for x increase from 0 to 1. All right. Now, if I say y is equal to a, y is equal to x, so not a, y is equal to x. So what happens here is object reference count for oh, sorry, it's like I'm mixing it up. So object reference count for 20. Okay. So let's get it clear. So it means that there's a memory location, a location in memory, so that holds the value of 20. So that location in memory is the reference of this value, right? So that location in memory is what we are talking about. That location in memory is simply labeled x. So x is simply a variable, it's not the object reference. The object reference is the location in memory. So when we have y is equal to x, so we are assigning a value of x to y, meaning that whatever is in this memory location Y is also referencing that same memory location, and in this case the object reference count, it increases as well, and so on and so forth. So I want you to study this and see, make sure you understand how it works. Again, if we say z is equal to y, so again we are still talking about the same reference or the same location in memory. Remember that y points to the same location, and at this point z is now also using this location. So it's the same location in memory that continues to increase. So if we now say delete x, so this deletes the x reference to this location, because at this point we have x is pointing to this location, y is pointing to it, z is pointing to it, so we have 3, the reference count to be 3. So if we delete x, the x reference to this location is deleted. So at this point we have object reference count decreases by 1, and so on and so forth. So this is about garbage collection in Python. Do you need to know about this? No. It's simply, do you need to use it? Not necessarily. You simply need to know how it works. Then that is how object reference counts is used to control garbage collection in Python. So in the next tutorial, we now continue with inheritance. We are going to be talking about inheritance in Python. So inheritance is the main, the key object-oriented programming concept you need to know. So before I continue, I'd like to remind you to subscribe by clicking on the subscribe button below. Alright, so inheritance allows you to create a class that inherits from an existing class. You do this by placing the existing class name in brackets after the new class name. If you do this, you can use the attributes of the parent class in the child class. So let's assume we have our student class as well. So let me just let me copy the student class so that we'll see if we can inherit the student class. So the student class we created in tutorial 2 of this series, or part 2 of this series. So let's get back to inheritance. So let's say we have the student class here. Let's take out this so that it becomes a bit clearer. Alright, so this student class have certain things. For instance, it has number of students, it has race, no, first name, last name, it has this function display count, and it has print method. Alright, so assuming that you have another class, so let's call this class to be, let's call it pupil. Okay, so let's say class pupil. Remember that pupil is also a student that has everything that a student has. So if you want this class to inherit everything from the student class, you simply specify in bracket, you simply specify the name of the class you want it to inherit from, so student. Alright. So at this point, unresolved reference, right? So, okay, class pupil student, okay. So it means that we need to write some things here. So let's say we have a function, let's call it sorry, we need to move this back. Good. Alright, so let's say we now have a function to create a new pupil. So let's say def pupil, sorry, init, and we have self, and let's say we don't have any constructor, and we have, if we create a new pupil, we want it to display this is a pupil, not a student. Okay, let's assume something like that exists, so you can have a pupil that is not a student. So we have created a class, and this class inherits from student, meaning that if we go ahead to create a new object of pupil, let's say P1 is equal to pupil. Alright, so now we've created a new pupil. Remember that when you have in a function, in a class, you have this init here and you have also init here. The one that takes precedence is the one that is in the child class, because in the child class, so we have this class to be, we call this class to be the child, and this student class now is called the parents. It's also called base class, and it's also called superclass. Alright, so this is called the child class. It's also called derived, and it's also called subclass. Alright, so these are things you need to know. Alright, so we have all indent does not match any. Okay, so just don't understand why this is giving me this error here. Alright, so I think everything is fine. So if I go ahead to run this, it should not give me an error because so definitely okay, so not on indenting anything. Alright, so this is quite not clear why this error is coming. Okay, so because it's telling us on indents does not match any indent. Okay, so one more space. On indent does not match any indentation level. Okay, so let's see. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we take out this. So one thing about programming is you need to learn how to, you need to have good debugging skills. Alright, so we have P1 equals pupil. Alright, so we have P1 is equal to pupil, right? Good. So we created a new pupil, and this, okay, so we say it's missing 3 required parameters. So we have this init. Okay, so let's see. Let's say we have first number is 01, and the first name is Kindson. Forget about this title. Alright, so if I run it, everything is fine. So now this pupil is being created, and you cannot create this pupil without any parameters. So we have these parameters here is actually coming from this place. So let's now print the number of students at this point. So let's say print P1 dot number of students, and you can see it works perfectly, and it prints number of students is equal to 1. So number of students, where is it coming from? It's coming from the parent class. In the same way, I can say P1 dot print students. That is, I can call this P1 dot print students, and if I run it, it's going to work and also print out the students. As you can see, there are some things you need to know about inheritance in Python, and that is, inheritance in Python is something that we can have multiple inheritance, and we can also have two methods, is subclass and is instance, and we can also have overriding. So let's start with the first one, multiple inheritance. Multiple inheritance is a situation where a class inherits from more than one parent. So let's see how it works. So let's say we have a student class and we also have person. So we have another class called class person, right? On this person we have a social security number. So we have social security, DEF, elites. I have SSN. Alright, so this person has SSN. I have self.ssn, self.ssn equal to SSN. Alright, so we also have person at this point. Alright, so let's also define. Okay, so let's leave it this way. So when we have pupil, assuming pupil wants to inherit from both students and also inherit from person, you can simply place the two parent classes inside here. So you can say person, because of course a pupil is a student and a pupil is also a person as well, right? So assuming we have let's say nationality. Say nationality equals Nigerian. So it means that at this point I could actually say P1 dot nationality, and you can see you can reassign it to whatever you want. So you can say Hungarian, because right now I'm in Hungary. So what we are saying now is that this pupil, P1 is a pupil object created from pupil, and now P1 is using the constructor. This constructor is coming from student, which is this constructor here. And then P1 does nationality. This nationality is coming from where? It's coming from person. Remember, P1 doesn't have that constructor, and it also doesn't have nationality. All these are coming from the parent class. What are we saying? That we are saying that a class can be derived from two classes, and this is what is called multiple inheritance. That is where Java fails and Python wins, because Java does not directly support multiple inheritance unless you use interfaces. Even at that, it's still not the same as multiple inheritance. So we have these two methods you need to know: is subclass and is instance. So a subclass checks if an object is a subclass of another object. For instance, we want to check if P1 if P1 is if pupil is a subclass of person. You can say pupil dot is, so you can actually use is subclass of, is subclass of P1 and person. So we are checking if P1 is instance of person. So okay, we are saying instance, so let's print it out. The answer is going to be true because P1 is instance of person. Alright, so if I print it out, it says true. P1 is instance of person. So is P1 instance of, let's say, students? The answer again is true because P1 is instance of student. Is P1 a subclass of is subclass? So the class now is, let's check if the pupil class is a subclass of the student class, and the answer is going to be true. Now let's check if the student class is a subclass of the pupil class. So student class is a subclass of pupil class. And the answer is going to be false. It doesn't work. So that is about a subclass and its instance of. Now we have overriding. As I've mentioned sometime before, overriding have to do with you have two methods with the same name in the parent and the child class. So let's clean up this place a bit. Alright, so again I'm going to take out this person class. So we have the child class inherits from the student class, inherits from the pupil inherits from the student. And now I want to say I want to have another method called print student. So print student is going to print say, hey, I override my parent. Alright, so now when you call p1.print, so if I create the one new pupil, p1 is equal to pupil, and I give it a parameter. The number is 001, 003 or something, and the name is kind son, and the other name is Munye. Right, so now if I say p1.print student, the question is, what is it going to call? Will it use this print student or will it use this print student? Now it's going to use this one because this p1 is defined in the child class and it overrides the one in the parent. So if I run it, it's going to say, hey, I override my parent, because this print student has the same name in both the parent and the child class. The one in the child class is going to override the one in the parent class. So that is how overriding works, and I'm going to stop here for now. So we are now going to continue in the next part when we are going to be looking at overriding, base overriding methods. Today we are going to be taking this short part, which is base overriding methods. Before I start it, I'd like to let you know that every class you create derives from some parent called object. So this is an inbuilt base class where every class derives from. So now there are some built-in methods that you can always override, and these methods are given in the table below. So these built-in methods, the names always start with double underscore and end with a double underscore as well. So for instance, when we are creating a new class, we have this init function or this init method. So this init method is actually overriding. So this init method is defined in the base class of object, and now you are overriding it by redefining it here as well. So now we have other methods that you can also override. For instance, we have the del method, we have the repr method, we have the str method, and we have the cmp method. So these are methods that you can override. So let's take, for instance, you want a string representation of these objects, right? So now one thing you can do is to write a method, for instance this. You can also write a method like this. But I actually have written this method which overrides the str method. So we want a string representation of the students, of the particular student object. So the string representation may be something like this. Let's take, for instance, we have return, we have self.rational, and then we have a little space, or let's say this this column, and let's append the first name and the last name, and then we add the last name, self.last name. All right. So let's assume that we have the string representation to be represented in this way. So we are overriding this method to create a string representation of this student. So let's say we create a new student object. Let's say let's just call it student1 is equal to student, and we specify the reg number to be 001, and we have the first name and we have the last name. Okay, now if we want to display the student, we can just say student.student1.string. So we can just say print student1.str. So that is how easy it is. So we are creating a string representation of the student object. So in that way, we simply have, this is what we'll have. So it looks more, it makes a little sense, and it's a little clearer to have a string representation. So instead of writing a method that says print student and you start writing a print statement, you simply create a string representation of this. So try to see how every other method works. For instance, delete. You can write a method that displays a message that an object has been deleted when an object is deleted, and so on and so forth. So this is also one of those topics you need to just know. It's not something you need to get too much involved with. Just know that there are some base overriding methods that you can actually override. Today we are going to be talking about operator overloading in Python. Already you know about method overloading, where you overload methods. That is two methods having the same name but doing two different actions. In this case, we are going to be talking about operator overloading. Of course, you know operators are symbols you use to perform operations using two operands on both sides. So we have something like the plus operator. You can use it to perform addition of two numbers, but can you use it to perform addition of two vectors? The answer will be no. So let's take, for instance, we have a class called vector, and this class is a class where you have a vector is made up of two items. So in mathematics, you have these two items are magnitude and direction, but here in programming, items can be actually anything. All right, so now we are now going to write a class where we are going to override the add operator to be able to perform addition of two vectors. So let's copy and paste and then explain it instead of typing it out, because we could save some of the time. Alright, so this code is on my website, so you can feel free to copy. So let's assume that we have, let's say, okay, so okay, let's start by let's say v1 is equal to, okay, so let's look at this class. Class vector is defined by two variables x and y. Now we have a string representation. You already know this. Return the string representation of this vector. Now we want to perform addition on this vector. We want this vector to use the plus sign to add two vectors. So in this case, if you have two vectors, for instance 520 and 210, the plus operator should add it in such a way that it will add the first two and add the second two, and also return the two, and then return a vector that represents the new addition of the two. Okay, so if I run this code now, you can see it gives us vector 7 and 30. Now I'm going to actually display the first two vectors by calling the string method. So I can say vector1 dot str, str, fine, okay, So I'm going to print it for sure. So print the vector1.str. Right. Again, I'm going to print vector2.str to v is vector2. So this is vector2. So if I go ahead to run it, so you can see it says vector, this is vector1, this is vector2, and this is the type vector. So you can see that it performs addition on the two of them. So what are we saying? That we are saying that at this point we perform operator overloading at this point. For the add operator or for the plus operator. So this is basically where you will do the magic. So we have self.x plus vector self.x plus we have vec.x self.y vec.y. So what we are saying is we have self, meaning that the current vector is the first variable and the second variable is another vector. So we are just saying we sum up the x and also sum up the y and return a new vector. So basically that is how it works, and that's how operator overloading works. Try to get your head around it by copying this code, pasting it, try to change up some things in it and see exactly how it works. Now, data hiding is a very important concept in object-oriented programming. If you know about Java or C++, you may have heard of something called access modifiers. So these access modifiers are something like private, static, and protected. In Python, we don't have those keywords. So how then do we achieve data hiding? Meanwhile, simply put, data hiding is used to hide internal details of a class, more like you are defining an attribute as private. So when you define an attribute as private, it means you cannot use this attribute it means that this attribute is accessible only from within the class. So let's illustrate to see how this actually works. So I'm going to delete this that comes from tutorial 8. So basically we are taking the last tutorial at this time. So let's use this class for example. Meanwhile, let's see. Such attribute is not visible outside the class. To achieve this, you will have to name the class with double underscore. The attribute with double underscore, right? So if you name the attribute starting with double underscore, it means that we can consider it as private. So it means that outside the class will not be able to access it. So for instance, we have this employee class here. Why do we have this error? I don't like these errors here. So click all this. Okay, go away. So when we try to print employee.mcount, it will yield an error. But inside here, we are going to have it's going to work correctly. So if I print it, it's going to say employee object has no attribute mcount. So at that point, we can see that outside this place it doesn't work. But if we want to access the mcount, it means that we can use this count function. We can just say m1.count. So that is the only way. So this is about data hiding. So just know that if you use double underscore in the name of a variable, then it means that that becomes a private variable. So this is how we come to the end of our object-oriented tutorial in Python. I'd like to thank you for viewing. I'd like to also ask you to check out the advanced tutorials and also try to go around the Python tutorials in my website. These are explained very easily and very clearly. Remember to subscribe if you've not subscribed, and also like this video, leave a comment, and also look at the notification button out beside the subscribe button below this video and click on it so that you get notified when I make new lessons. And also if you have some questions or some challenges in programming you want to let me know and I can help you, then leave it in the comment box below. For now, I'd like to thank you.